Thank you, Dr. Patel, for being here. One of the first questions we want to ask you is that what do you see as the most underappreciated role of mitochondria beyond energy production?
It's a good question. I think most people learn very early in high school or now even grade school that mitochondria are the powerhouse of the cell. And when you learn something about something, that tends to focus where you think about stuff, right? And so no one learns anything else about mitochondria. So completely true. They are the powerhouse of the cell. Without them, we don't make energy. Without them, we don't survive. We need them to grow, move, do all the things we do. I think the underappreciated thing that we're really after, and one of the things we've been thinking about in the lab, is how they move dynamically and how are they structurally constructed, right? So there are different shapes and sizes in every cell, and that shape and size gives them function. And so most people tend to think that function is a consequence of some sort of reaction, right? And we have a very early opinion of this that function is a consequence of structure. And so structure determines what mitochondria do, how they behave, how they interact. And this is, I think, the underappreciated part is they are an organism that got incorporated into us. And so it's a coevolution of a symbiosis, right? And so one of the things that I think is underappreciated is they are an organism, right? A living organism living inside us. And they have all of the same requirements. They're social, they like to interact. When they're close together and they're dynamically shaping and shifting, they create a lot of resiliency in a cell. When they separate, just like in humans, when you're isolated, you become very toxic, right? And aggressive and reactive. And this is what mitochondria do. And I think that's the underappreciated part of
What's the biggest unanswered question in mitochondrial biology today, and why is it so hard to solve?
them. I've got to think about this. Um, I think the biggest problem that we're trying to resolve is a lot of people think, and I think there's some truth to it, that mitochondria are the end effect of disease processes, right? They are consequential in creating a disease entity in some way or another. They are key to aging and other things, but we don't know if they're the primary thing, right? And so this becomes really important. If they are the primary cause of a lot of these diseases, then we're screwed. We can't do anything, right? Once they're destroyed, once they move into that phase of non reversal, you're on this path where you're going to get destruction. Turns out when we think and we look at a lot of chronic diseases, if you start eating well, if you're starting exercises, you get sunlight, if you do things that are natural and heal, mitochondria can revert back. So this suggests that they're potentially a reflection of an end or a start of a disease, but that they may not be the primary cause, right? And I think this is an important thing to realize that if you could figure out how they're dysfunctioning or if there's an environment that creates mitochondrial dysfunction, could we actually change that environment to then change mitochondrial function? And so I think this is one of these barriers that we're facing is there's a lot of thought that makes them the causative factor in disease, and they may be one of many things, and it may be that you can rescue them, right? And that's, I think, the critical thing we need to figure out.
Wow, thank you for sharing that. Um, After this question, I want to ask you that how does mitochondrial dysfunction could contribute to complex diseases like neurodegeneration, cancer, or even aging?
Yeah. Um, all these, all of the processes that we have in our body, they're tied to energy, right? Um, if you don't have energy, you can't continue to do those things. Biochemistry is very important, and mitochondria are key to that. They use oxygen. They use certain factors and fuel states to make a lot of energy, and this allows us to do all the crazy, amazing things we do. One of the things that happens in chronic diseases, cardiovascular disease, neurodegeneration, cancer, all these things, is that they cause a change in the energetic calculation, right? Either you're consuming too much energy or you're not making enough energy. And all of this then is a consequence of what the mitochondria can do. They're the gatekeepers of this energy. And if they can't make enough because you've damaged the structure or the environment that they're in, that they can't perform, or if the system requires a lot more energy to survive and adapt, then the mitochondria just can't keep up. They exhaust, right? And so that's the aspect of chronic disease in mitochondria, is that they create this resource that is limited in unique ways.
Wow. And you're in the world of research, and I'm wondering that what are some new technologies in the world of research that could potentially help us in the next 5 to 10 years to change medicine?
Yeah, I think the hot area right now is the origin of mitochondria becomes interesting to this, right? So they are old bacteria that got incorporated into living systems and they've evolved over billions of years to be where they are now. If this is true, then they still retain some of that primal aspect of what it is to be an infectious organism. So, what companies are trying to do right now is can they actually isolate mitochondria from a healthy source and then inject it or deliver it to living systems that are mitochondria compromised? If they are infective and can get in, and they can, right? Delivering mitochondria to the heart or to the brain, you may be able to repopulate dead, dying mitochondria by a new source. And I think this is the future of mitochondrial therapy is mitochondrial transplantation and delivery into living systems, which is going to be crazy amazing to see.
Has that been done so far?
There's experimental evidence to suggest this, and there's few companies that have now formed that that's their main focus, and so it's coming.
Wow,
Right?
so exciting. Are we even close to developing any effective therapies for mitochondrial diseases, or we still need more time to come up with something?
Yeah, I mean, there's peptides that are being developed and in clinical trials that target mitochondria. SS31, there's a company developing it for all kinds of diseases. Like I just mentioned, right? Mitochondrial transplantation. There's companies that are investing hundreds of thousands of millions of dollars into developing supplements that target mitochondria. The problem with all of this is how do you figure out who needs to get which therapy, right? And so there's a barrier there. Unless you can test mitochondrial dysfunction, you can't determine the therapy that's needed. And unless you can test mitochondrial function, you can't determine if that therapy is actually working, right? So that's the big limitation. And this is where I think Versea Discovery comes in and solves this problem in a global way. And there's a path forward now, right?
What are some lifestyle or environmental factors that could help with strongest influence on mitochondrial health?
Um, yeah, so I think in thinking about lifestyle, right, there's lots of things that we do and we can control that we don't do well. And these are what lead to chronic diseases, right? We live in environments that are toxic. We drink alcohol, we smoke cigarettes, we eat things that we shouldn't be eating, and we can regulate all this. Um, the problem why it's such a huge epidemic in the world is it's really hard to control, right? We have desires and wants and wills that limit the ability to do that. People who can maintain diet and exercise and activity and sunlight and movement and those kinds of things tend to be well adjusted. And those are the simple things you can do. Um, in the meditation stuff, we've been thinking about this in a unique way, and it's how you think, act, and feel. But this thinking, acting, and feeling is a consequence of those choices you make. And so, I mean, the simple ways to do it is if you eat well, if you actually learn how to breathe, right? Most people don't breathe in the right way, and there's correct ways to do it, incorrect ways to do it. Most of us are mouth breathers, and it turns out you should really, for health, breathe through your nose. There's a recent paper that came out that suggests that there's a fingerprint that can identify to almost 98% accuracy whether someone has depression or is healthy based completely on the pressures they generate in terms of breathing from their nostrils, right? So this
That's
suggests
crazy.
that our brain controls a very simple act that every one of us has to do. And this ties to mitochondria, right? We breathe to bring oxygen in, and that oxygen is used as a resource by mitochondria to make energy. But if you don't breathe the right way, you're bringing things in different patterns, and you've got changes in your nerve activity and other things that lead to dysfunction. And so they're simple things: eat, sleep, walk, move, exercise, breathe, and you'll be okay. But it's so hard
Hopefully.
to do. So hard to do.
Oh, I bet. especially for scientists like yourself.
Yeah.
Busy. And how can me screen potentially be used to detect early signs of dysfunction or even before the symptoms are present?
Yeah, so the limitation with mitochondrial testing has been um, there's nothing comprehensive. So we talked about this. Mitochondria make energy, they move, they're dynamically shifting, they dysfunction in unique kinds of ways. And so if you're going to measure mitochondrial function, you can't use genetics to do it. They're a dynamic organelle that's constantly doing stuff. And genetics is your DNA that's there when you're dead or alive, right? It's the same thing. So how are that going to tell you what a dynamic system is doing? The other thing that people use are static biochemical tests, right? So if you look at a handful or a single biomarker, they can theoretically predict what your mitochondria are doing. Impossible, right? Especially if you're looking at it in urine, something you're excreting, and not even blood. And so where MeScreen excels beyond all of this is that it doesn't care about your genetics in a direct way. We are looking at genetics in an indirect way. And it doesn't care about a set of biomarkers. It looks at everything you're creating. So with the poke of your finger and a couple drops of blood, we're capturing everything that you make as a consequence of your environmental exposure, your genetics, your microbiome, your mitochondria. All of these things are creating a complex you, which is captured in blood. And instead of limiting it to one or a handful of the things in there to figure out what you are, we take the entire you and in MeScreen, we move it to a cell that's never seen you. This cell has mitochondria, and now we reflect to see what those mitochondria are doing when they're existing in your personalized created environment. This now gives you a full picture of what your mitochondria are doing. We can look at functionality, we can look at dysfunction from a reactive oxygen species generation, and importantly, we can look at the dynamics. How are your mitochondria, or how is your environment shaping how your mitochondria move and dynamically shift? By understanding the function, the dysfunction, and the structural dynamic aspects, you get a complete picture of who you are from a mitochondrial perspective. And now you can make those decisions. Are the things you're doing to advance your health, well-being, or disease you're dealing with, are they working, or do you need to alter them in a unique way? And now you have a way of figuring this out.
That's amazing. And would you recommend me screen for kids as well?
We've been thinking about that. I think if you're living and breathing, and if you're dealing with any kind of issue, you should probably know what your mitochondria are doing. If they're behaving normally and everything looks great, you do the test maybe once a year, or unless you feel really horrible or sick, you can do this and see what's happening. Um, but if there's some sort of chronic thing that you're dealing with and you think that energy and likely energy is involved, it can't hurt to know what your mitochondrial state is. And kids, we may see that this could be an interesting test to use in children who have lots of things, right? It's not a diagnostic, but it does give you a very easy, clean picture, and it doesn't require muscle biopsy, which is typically how you measure mitochondrial function, which is painful. This, you poke your finger. Kids don't like their fingers poked, but it's transient, it's quick, right? Get a couple drops of blood and you're done.